Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Well, hey there, and welcome to another episode of the Digital Enterprise Society podcast. Thank you very much for tuning into this show. We appreciate that you've come along on the journey that we've had over the last year and a half as we have designed this podcast to be a resource for those who work in and around PLM. The Digital Enterprise Society, it is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to be the co-host of this show. And I co-host this show every week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig.
Hi, Tom. It's good to hear your voice. And, every time you introduce me, I feel older. So maybe I just should get old, right?
Every time I introduce you, you are older because we film we record this every week.
Yeah, well, I thought I would be rejuvenated and feel youthful doing this. And maybe it's just the time of year, right? It's really foggy and cold and rainy today where I am. So it's just ready for winter.
It's a beautiful fall day in Texas today. In fact, in October, I like to refer to Austin, Texas's weather as San Diego. We get like 1 month in the fall and 1 month in the spring where we have perfect weather. And I'm living that today. So,
well, I wouldn't mind visiting you, but these conditions kind of prevent that. So we'll keep doing the virtual thing.
Yep, we'll do some more live episodes as soon as the world returns to normal, where we can sit face to face with our guests like we did last year. Hey, Today is going to be a great talk because we're talking to somebody. They're working on a fully electric airplane, and that is kind of exciting to me because it's I like anything that's innovative and different, and I'd love to see their project work. We've got Jim Forrester with us today, and he is the director of engineering at GE Aerospace, and he oversees a team that's their job to design this airplane. Their team of subject matter experts, and his job is to make sure he enables them with the processes and tools they need to make this a success. So Jim, welcome to the Digital Enterprise Society podcast.
Well, thanks very much. I appreciate being here.
Yeah. So Jim, give us a little bit of your background. What were you doing before you were designing an electric airplane?
Well, a long time back, I had right out of college, I had a short stint at General Dynamics where I worked on the F-16s in Fort Worth. And then I went to GE Aircraft Engines at the time and spent almost 20 years there doing turbomachinery design, designing everything from the front end of the engine to the back and back to the front again, stators, rotors, most of the subsystems of the design. Towards the end of my career there, I really started to get in line and enabled with 3D CAD, specifically UG, which was owned by UGS at the time. And I showed a lot of innovation there and enthusiasm there. And one thing led to another, and I wound up leading the design, essentially PLM team at GE Aircraft Engines. And our primary focus was trying to use the CAD system and the out-of-the-box power that it had to create template turbofan engines in CAD. Mm-hmm. So when I left there, we had 3 engines and templates of them, and we could take the output from conceptual design, which is essentially a 2D flow path, and morph them from a generic template to a unique design, and then we could, based on that, flow all that information top down in a what we call a control structure using components and assemblies and wave in a very unique way, and then affect most of the components at the bottom. So we kind of in effect skipped over preliminary design. So that was very effective there. For various reasons, I left GE and I went to UGS at the time, which then became Siemens PLM, and had a nice career there, and then transitioned to director of detail design here at GE Aerospace, where when I interviewed with them, I presented basically that story and what I could do for them, and George Bai said, that's exactly what we want to do. So it was kind of an alignment of supply and demand. So it's been a fun ride.
So Jim, it's interesting you've been on both sides of this PLM universe, both as a user and one of the earliest users. GE was one of the places we visited from General Motors to understand how to do virtual engineering. That was back when I was just propulsion, and so an internal combustion engine and a transmission. But it's interesting that you then were able to take that skill or knowledge and put it in directly, if you will, with the folks at Unigraphics, and then had the opportunity to do a greenfield. So you've seen a brand new company. You've seen the application of tools within a big company and in a startup. And one of the things that fascinated me in our introduction discussion a few days ago was this point about using tools out of the box. You know, part of what I've always heard, both from folks in General Electric and General Motors, was, well, the tool vendor just really doesn't understand our business. And so we're always going to make customizations. If nothing else, it's our secret sauce. Is that what you've also concluded at GE or GE Aerospace, or have you got a different approach now?
We've concluded the opposite of that.
Oh, interesting.
The custom code, if that coder gets hit by a bus, you're in big trouble.
Yeah.
And what I've found in my career, both at GE and at Siemens PLM and all the clients that they had, was the more code you have, the more intractable you are with respect to being able to upgrade from version to version. You have to maintain that code that integrates all those systems together. And again, if you start relying to an extreme amount on that coding team, whereas if you do stuff out of the box, sometimes the integration is a challenge, but it's in the end more robust because it doesn't rely on custom code. And what I find is most big OEMs, they try and bring legacy processes and legacy applications into a new PLM tool suite, and they wind up coding the thing to death, and they code themselves into a corner, and they can't get out of it. When I went to AWG last fall, the Siemens team was presenting all these great new abilities and capabilities in the new tool suites and new versions, and almost to a OEM, they said, "This is all great. I can't get out of NX10. I'm stuck.
Yeah,
my matrix of NX, Team Center, doors, ANSYS that I've coded together is now fixed, and I'm stuck."
Right.
So
it's really interesting.
Yeah, and I knew this going into my career at GE Aerospace, and I said, okay, no code. We are going to have zero code, and we're going to only configure as minimum as we can.
Well, I think you're doing exactly the right thing, and I think to the older companies out there listening, this is what you should be worried about: is that there'll be a startup that'll use these very capable tools out of the box, and before you know it, they'll be in cycle times that are less than yours, maybe much less. And you know, the counter argument is some of that legacy coding is the secret sauce, right? Whether it's the way you do supply chain management, and car companies have a lot of that, or if it's just the way you manage risk and product introduction of new features. But I think you PLM leaders out there, you got to listen to Jim carefully. It's really not worth painting yourself in the corner. So you better figure out, no kidding, what is the secret sauce and nothing else. And you know what? In my experience, especially Siemens, we also used NX and Team Center at General Motors. You know, if you share that experience with them at why you needed unique code, it's not too many releases before you get that capability in the tool set, right? So, one of the things that's coming, Jim, in other industries is printed parts or additive manufacturing. Are you guys doing anything like that, or is that just something that's still too new, too risky?
The FAA is very adverse to new.
Yeah, so your certification, yeah, okay, well, yeah, because they don't know enough will be the argument, right?
It's a guilty until proven innocent a group of people, and so if we go with something that's already been proven innocent in their eyes, it's much easier for us. So we're trying to keep the plane. Yeah, we're trying to keep the plane as simple and traditional as we can. It's not a quadcopter where people walk into and a computer flies them someplace. Yeah. Good luck with that. Just having a normal airplane with a battery system and motors is proving to be incredibly challenging from an FAA certification point of view.
Yeah. Well, you can remind them it doesn't blow up like diesel fuel and electric spark. However, lithium-ion batteries have this annoying tendency to catch on fire every now and then. It's actually more on the charging cycle, which you undoubtedly do on the ground, right? I mean, you don't probably have regenerative charging in the air, or do you?
We don't. We only charge on the ground.
So the flow of current.
We've taken a lot of steps to ensure that there's no or minimal risk of thermal runaway in the batteries, and in the event there is, we have redundancies in the system as well.
Did you catch that term, Tom? Whenever we don't want to talk about what it really is, we call it a thermal event. Okay, so just wanted you to be aware. So an electric aircraft, it's been in the storybooks we all grew up with for a long time. And from an engineering point of view, it's great, except batteries are too damn heavy, right? And so you don't get much range or much power before they're depleted. What's made it possible now? Is it just battery advances, or is there some other things too?
It's essentially battery advances. The energy storage density to weight is at a point where it's just practical to do this. We also are focusing the product on a trainer. So we're not flying from point A to point B and doing a 5-hour flight. The technology isn't there yet for that. The batteries need to get lighter with respect to that. But and we'd also you need to make sure there's a charging system at point B, right? But from a training point of view, you take off from point A, you fly and you do your training, and then you come back to point A, you charge up, you go in and get your next student. They come out and do their walk around and do all that stuff. Maybe 15, 20 minutes, half an hour goes by. You're back up to 80 or 90% again. Right. And you can go do your routine again. So from a many cycles in a day, short cycles, it's very practical at this point. We've done a lot of pencil sharpening numbers, and our endurance is over 3 hours now. So it's quite within the full range of the training environment, including a cross country to and from flight.
Right. Interesting. So I did last long enough. I lived long enough to see those childhood fantasies that we read about in Popular Science or whatever other thing I read when I was 10 years old. So this is cool, and I like the way you guys you're focused on a market that has a need, and along the way you'll get used to being certified as an aircraft, at least in the U.S. Way of certifying things. And then as battery technology continues to improve, which it will, because a lot of people are pushing, right, from your business to car companies to a bunch of other people. So the thing called energy density, how much energy can we get per cubic foot, right, will continue to improve, and then that'll turn it into that longer range flight. So this is interesting.
Yeah, and the market key is simplicity. Mm-hmm. We only have one moving part, the rotor in the electric motor. So our maintenance costs are tiny. Therefore, our operating costs are about 1/5 of what a internal combustion similar plane would be, a Cessna 172. Our operating costs, including buying the plane, is about 1/5 of that. So again, for a training fleet that's doing rapid cycles, the maintenance is very low. Internal combustion engine has hundreds of parts in it that move, and we only have one. So that's real key.
You know, even the Wright brothers, if guys go back and study history, they wanted an electric motor for that reason, the simplicity that you mentioned, right? And then they were disgusted that nobody had figured out the chemistry to make a lightweight battery, right? And whatever the technology was, you know, original cars before diesel came along were in fact electric, right? Back in the 1880s, 1890s. And then diesel said, oh yeah, but if you had a diesel engine with a little bit of diesel fuel, you can go a lot further. And there you go. That's why we became internal combustion engine folks for the last 100 years. So interesting. Now, you and I have an aircraft background. That's what my education was in. And so we appreciate the importance of the center of gravity. And one of the things you guys presented at Realize Live was how you were able to do a redesign of the aircraft virtually in order to make this thing more stable in flight, where the CG matters a lot. And anyways, tell us a little bit about, you know, you're using out of the box tools. We got that, but you were able to redesign your aircraft, stretch it a bit, move things around to get a better center of gravity. What was that like? I mean, did you get everything you wanted out of the tools, or did you have other things you had to do?
We got everything we needed out of the tools. Let's keep in mind, this is a team of only 25 engineers. The people
There's another embarrassing fact that you can do it with 25, but keep going.
The people who are actually in the CAD system, the double E's are working on electronics and logic diagrams and circuit diagrams and so on, which they're using Capital to do. Okay. But the 3D CAD people is 15 people probably, and the people who actually did the CG change was probably 8 people. And so what had to happen was we have a CG range of don't go have the CG go farther back than this or forward than that of about 3 inches. Now the batteries are unlike fuel. The electrons are just moving from one side of the battery to the other. So they don't move, they don't change mass. We take off with exactly the same weight and land at exactly the same weight. The only variable we have is the pilot. Do we have 2 pilots? Do we have 1 pilot? Are they a 95% male, or are they a 5% male? Are female, and so on. And so that variability of the pilots gives us a range of about 2 inches. So we have to get that 2-inch variation within a 3-inch sweet spot of do not exceed back and forth.
Right.
And the method we were using to design the plane was basically observing the weight and CG as we went along. We, in the conceptual and preliminary design phases, we targeted where things were going to be, but we had a lot of learnings. Some things got lighter, some things got heavier, some things weren't there in the beginning and they got added. So as a result of that, and observing using the NX tool suite to do the weight and CG, we're able to trend our weight and CG with time, and we could see it creeping in a unacceptable and wrong direction. And we decided, hey, we need to do something about this. We know what it should be based on the aerodynamic shape. We need to move it. So we evaluated many ways to do this using spreadsheets and so on, and basic hand calcs. But basically it came down to we had to move big things a lot. So the big things are batteries. We have 800 pounds of batteries in the plane. And so we have batteries behind the pilots and in front. And so and the CG of the pilots, I should say the CG of the plane with the pilots in it is actually just behind them. So we needed to move the forward batteries. We decided, the rear batteries 8 inches forward. Okay. Which is a huge change.
Yeah, a structural change.
we had to, yeah. But then we had to move the forward batteries, and they have a moment arm, right?
Yeah,
so they
right.
have more effect. Moving them farther has more power than moving the ones that are closer to the CG. We had to move them 4 inches forward. Well, they're already completely confined within the forward compartment. So what this meant was we had to stretch the plane in front of the pilot's feet 4 inches forward. So basically, we had to reloft the plane to do all this. But we didn't recreate. We have a aerodynamic shape, what's called the outer mold line in the composites world, and it's associated to all the parts. So, and it's driven by sketches and basic out-of-the-box freeform shapes and so on, no code.
Yep.
And what we did was we simply modified that. It's all driven by parameters. We essentially stretched it forward. And then using that top-down structure, we propagated that change down to the primary structural components, and they all updated. And that was all done within NX in what we call the D-BOM, the design BOM. And it consists of about 300-ish parts. Now, keep in mind, there's almost 1,000 parts in this plane, 2,500 to 3,000. We only want to do this with the main part we're designing, those 300 parts. And when you look at those 300 parts, that's the plane. You go, oh, if a Martian came down, they'd go, oh, that's a plane. Everything inside, we're basically buying. So we're not designing those things.
They come in a center gravity of their own, and you got to put them wherever it meets your performance needs.
Exactly. So after we moved the primary structure and we had our new design space, 4 people went in and grabbed those 2,500 or 2,000-ish parts, and they moved them forward. If they were behind the pilots, they moved them 8 inches forward. If they were in front of the pilots, they moved them 4 inches forward. They did this all at home during COVID on their Wi-Fi's through a VPN on servers that are outside my room here in a closet. So it was really amazing, and they did that in less than 1 week.
Wait. If we did this kind of thing with a car, it would be even virtually, it would be many weeks, right?
Yeah, well, they essentially, these 8 people redesigned the entire airplane in 1 week.
Wow.
That's the power of top-down design and doing it in a way that the tools are now capable of.
Yeah.
Don't think of CAD as a 3D drafting board. Right. It's way more than that. You can do incredible things.
That's why I wanted to chat with you guys, is because this executives at companies, they want to shorten time to market, right? And so you're like, well, if you had a smaller team and you kept them focused, and oh, by the way, you gave them virtual, well, let's just call it tools that can let them work anywhere, right? Whether they're cloud-based or you have your own servers there that they can access from home. It is rather amazing what can be done. And I think if you're in the workforces out there at those large companies, you should really stay aware how fast this can change, right?
Well, that's the key word, is change.
And staying focused on the right changes, right? This is something else you guys talked about at the conference. It's just the program management team. You had this one slide that I found fascinating about knowns and unknowns. And so you go across your development cycle, and the goal is to turn unknowns into knowns, right? And as a management team, you kept those in front of you, and and when you got the knowns to some percentage, 80%, 90%, or whatever, you knew you were close to the end and ready for the scrutiny from the FAA or whoever else to kick in. So the program management aspect of this is also really beneficial. Instead of asking for a bunch of status in Excel or, gosh forbid, Word documents or PowerPoint, now you as the leadership, you can go examine PDM and see where things are at, including this redesign you just talked about. So what do your decision makers, yourself and the folks around you and above you, do they use Team Center day in and day out to get their job done?
The individuals who are designing the airplane use it constantly. So NX and Team Center, and primarily NX enabled by Team Center, and they use it as essentially a design sandbox. They can pull up the engineering BOM, we call it the bottoms-up build of the plane that has all the primary structure and all those parts that we buy. It has everything. And they can collaborate on that. They can have design reviews. They can have a workshop. How are we going to mount this particular thing? Right. Let's look at the design space. So they constantly use it. I am the director of design, but I do know how to use the tools. So I'm the one who essentially facilitates myself and above being able to look at the status of the plane. And yes, turning unknowns into knowns, that's the key to the whole thing.
Right.
So in order to do that, things have to change. And OEMs, in my experience, traditionally abhor change.
Well, yeah,
we can't change anything past this particular toll gate. And in my experience, every single time I've been on a program, at the very last moment, a critical change happens.
Yeah.
And there's no mechanism to facilitate it. So when I came to Aerospace, I said, using this top-down method and this bottoms-up BOM, you can anticipate change, embrace change, and actually use it as a competitive advantage so that instead of bringing a compromised wrong product to the market slowly, you can bring the right market that's been optimized to the market fast.
Well said. Bravo. So you touched on something I want to go back to. You talked about a design BOM, and now you just mentioned an engineering BOM. And I think the difference is the design BOM are the parts maybe that you're manufacturing, and engineering BOM is all the other parts, including the design BOM that has that. Did I get that right?
That is correct. They're two separate structures in Team Center and the CAD system NX.
Okay.
We've divorced them on purpose. So we have a design BOM that has the aerodynamic shape at the top and propagates that information, breaks it into its smaller building blocks, its smaller components. So a wing, a fuselage, a horizontal tail, and then an upper and lower surface of the wing, and so on. So that at the bottom of that, we have about 300 parts.
Yeah.
And then we bring them into the E-BOM bottoms up, and they're all designed in product space.
Right.
So when we bring them in, they provide the context of the design space, and then we're able to simply bring in as assembly components all the rest of the parts.
Yeah.
And we just place them.
Yeah, it's a packaging job. You just make sure.
Exactly.
Right.
Exactly. It's just a space claim job. But then once we have all those things in place, we have to connect them all with the harnesses, right?
Yeah.
And being an electric aircraft, we have a lot more because we don't drive things off of the engine anymore. We have to drive them off of the batteries. So that means more wires. Yeah. So that's kind of the last
bigger
glue.
Wires. Right? Yeah. The wire that goes to the motor, right? One last thing that then keep going for a second. So what is manufacturing used? Does it use the design BOM or the engineering BOM? I get final assembly might need the engineering BOM, but the guys building, well, you're probably doing carbon fiber, but molds or dies or however you're doing it, they could probably do it from the design BOM. Am I thinking the right way? What's your manufacturing BOM? What's it based on?
So the manufacturing BOM is actually down the road a little bit. So we have these two primary BOMs, the design BOM and the engineering BOM.
Okay.
Now, that engineering BOM organically grew from the design team basically based on function. Okay. So we have 4 departments. We have a high voltage team, a low voltage team, a structures team, and a mechanical systems team. And so to facilitate easy read-write access of all that information for them and ownership of that, they have that BOM broken up into those departments. That is not how the plane gets assembled.
Right, of course.
And for our purposes, it works really well for us from the design side. Now, the FAA is a totally different thing. They have to approve each component. They have to approve each assembly of how it actually gets assembled into the plane, each subassembly, each next node up to the entire plane.
Right.
So they don't want to see it that way. So what we have to do then is we have to use the Team Center manufacturing tool suite to copy every single component from the E-bomb into what we call the I-bomb, the installation bomb. And that is what will actually be configured, controlled, and managed with the ECO process. And that's what the FAA will see. They will never see our design bomb or our engineering bomb. They are only engineering tools that allow us to output a installation bomb. So that is what will traditionally be what most companies call their E-bomb.
Right.
Then manufacturing will pull information off of that. They'll create their M-bombs off of that. We'll send that I-bomb to the ERP system.
Okay.
So it's kind of a buffer area, but it's something that the FAA, working with them, we're required to have. So, most companies don't need that. They can just go with the E-bomb, and that's fine.
Yeah.
Or what we call the E-bomb, which is a functionally based bomb.
Correct. Yeah, it depends on the field, right?
Yes.
There are places where people have misbehaved and meaning they've made terrible quality decisions, and so there's now more regulation in how you assemble certain things, right? And I don't expect that will ever change, whether it's a car or a can that holds aerosol spray, right? So anyways, Jim, you did a really good job explaining the different bombs, and this is and that'd be my last question, but I think this is one thing that people tend to not think enough about when they think about virtual engineering. It's the fact that you have these different views, these different ways that you want to look at information. And also it's your point about knowns or unknowns to knowns. It's how you go about making decisions, right? And so having multiple bombs, while it sounds wasteful, it's actually quite purposeful because it serves the audience that has to make the next set of decisions, whether that's approving a design, certifying it, or whether it's coming up with moving of the center of gravity in the good example you gave us. So anyways, so any regrets on being out of the box tools, or just wondering why you didn't do it sooner?
No, I thoroughly believe in being out of the box.
Okay.
The other thing that we do totally out of the box is we use in the E-bomb that we have, and we have a weekly, basically an agile scrum meeting, and we configure that bomb based on out of the box releases. So as a design matures, we will release it at a out of the box 10% or 40 or 80 or 100% level, and that corresponds with passing through particular design review toll gates. So when we pull up the bomb, we only pull up the release stuff that the team wants to share with respect to that. So we manage the entire E-bomb on an imprecise basis using these release rules.
You know what? You said one more thing that would just spur another discussion, which is good. Seriously? You're doing aircraft design with Agile and Scrumming? Did I hear you right?
That is correct.
Whoa, cool! You guys are good. All right. Well, we've used up our time, so this has been fascinating. I like thinking about aircraft. I used to do it a long time ago. So thanks so much for being a guest. And Tom, I'll hand it back to you.
Yeah. Thank you. Before I let Jim go, I always like to try and get some of these guests to give us a little career advice for our listeners, because everybody who listens to this show is looking for information and they want to grow their careers. So, Jim, when you talked about your path in your career, you started off working for some what I would call sort of big bureaucratic companies. And now you've found a company that is kind of cool and I might say scrappy. How does somebody who's like, yeah, I want to work for a company that's doing new and innovative things, how does somebody make that transition?
That's a difficult question. I mean, basically, I learned a lot from a lot of other people, and kind of master your craft, understand what you're able to do. And I've kind of always thought a subject matter expert at a OEM should be a subject matter expert on the product. How is this product designed? Why does it look the way it does? And so on. From a PLM point of view, if you could understand the real capabilities of the tool and marry that with your knowledge of how the product is designed, then you're really in a sweet spot. Now you're an SME in both the product and how to use the tools to design it. There are very few people who know how to do both. And that was actually my launching point in GE into that template design team, where I had a very good and thorough understanding of designing the product itself, what made it tick, but I also had a very good understanding of how to enable that out of the box in the NX tool suite. And so that's why I got chosen for that role.
Oh, I think that's good advice. I think that's really good. So Jim, thank you for being a guest here on the Digital Enterprise Society podcast. And thank you. And thank you to everybody who tuned in. Join us next week for more thoughts, ideas, and information in and around product lifecycle management. Remember, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and create